It's often said that knowledge is the key to most questions that we have in our minds. In very much the same manner, at Quest, we try to provide you answers to many of the questions which come to our mind, but we do not know how things really work. So, before going any further, let me welcome Dr. Jayanta Sthanapathy of the National Council of Science Museums. Please give him a big hand. How are you, sir?
I'm fine. Yes.
The two participating teams, the one on my right is the J.C. Bose team, and you are?
I'm 𝐃𝐞𝐦𝐨𝐬𝐭𝐫𝐚 Chatterjee from Don Bosco Park Circus.
I'm Rahul Chatterjee from Don Bosco Park Circus.
I'm Goirik Sharkar from Don Bosco Park Circus.
Nervous?
Nope.
Nope.
Not nervous. On my left, the C.V. Raman team, and you are?
Pooja Krishnaswamy, Assembly of God Church School, Park Street.
I am Trishul Shah from Assembly of God Church School, Park Street.
I'm V.R. Krishnan from Assembly of God Church School, Park Street.
Welcome to our show. Let's give them a big round of applause. The format of our quiz is very much the same as in the past weeks. 7 questions in all. The first 4 are direct questions. 20 points if you get them right, that is if you get them on your direct tries. At the end of 15 seconds, if you do not answer, they pass to the other team. The other team should be ready with an answer at that time. If they are not, we go into the audience. But if the other team were to get it right, we give them 10 points. The last 3, that is the last 3 questions, will be on the buzzer. More about them when we get to them. So without wasting any further time, let's get down to quizzing. The very first question is for the J.C. Bose team, which is seated on my right.
Here in front of you, you have the first electric motor of the world. Do you believe that? This was devised by Michael Faraday in 1821. There's no wheel here, only a wire, straight wire, which is moving round a magnet. When I'm passing current through these 2 terminals, this one and that one, it makes a circular motion. If I stop the current, it stops. Now my question is, why the wire is circulating in this particular arrangement?
So inside the beaker there is a magnet, bar magnet.
Yes, this is the magnet.
And the liquid is mercury.
Right.
And when the electric current passes through the wire.
Which wire? This wire?
This wire and into the mercury and through that wire.
And through this wire. Right.
And the magnetic field is also present, the electric field is also present.
Okay.
So there is a force acting on that wire, which makes it move.
The 2 vectors, the magnetic field vector and the electric field vector,
yes,
vibrate in fields mutually perpendicular to each other. Now the resultant vibration of the wire which is produced, which we see as the visual
the
effect,
resultant force acting on the wire is at an angle which makes it
oscillate around the bar magnet, which makes the bar magnet, the center of the bar magnet, as the center of oscillation of the wire as it keeps going
so
around.
2 forces are acting on it. One is the magnetic field, and the wire which carries current also behaves like a magnet.
Exactly, yeah.
What you have said, I am explaining in a different way. So your answer is absolutely right, and in this case, this is oscillating, sorry, this is not oscillating, this is rotating in anti-clockwise direction. Now if I change the direction of current, what will happen? This will move in clockwise direction. Let us see what happens. Yes, this is in clockwise direction. So incidentally, this is the first electric motor of the world. Very important invention to our society. So they have given the correct answer.
That's a big round of applause for them. We found all 3 forces acting in unison here. All 3 of you. Shaunak, Rahul, and Goirik. Well done. 20 points for your team. Dr. Sthanapathy, anything further to add?
No.
So So the JC Bose team is on 20 points and yet to open their account. CV Raman team, the next question is for you.
I have a round bottom flask here and some water inside. 2 tubes are fitted to this through a cork. One side is closed, the other one is open. Now I'm inverting the flask and putting this tube here. And removing the stopper from this tube. The water comes out inside the flask in the form of a fountain or jet. Okay? You have to explain why.
When we invert the straight tube into the water, we are inverting it into a beaker of water.
Right.
The U tube is inverted into a bowl containing nothing. Water starts coming out of the U tube, the full
through this tube.
Through that tube.
Yes.
And so the water in the round bottom flask decreases.
Yes.
As a result of which
partial pressure is
partial pressure is created as a result of which
partial pressure is created.
a vacuum is
a
created.
partial
vacuum is created,
which
right.
sucks the water from
Yes.
this beaker back, which comes out of the nozzle as a fountain.
Very easy, right? Okay, you get 20 marks.
Dr. Sanapati?
I would say the same thing, you know. This bent tube draws water from this flask. And because of that, it creates partial vacuum inside the flask, due to which water is drawn from the large beaker and the water comes out in the form of a jet. That's the correct answer. That's the answer which you have given.
Well done then, CV Raman team. 20 points to you, and the next question goes to the JC Bose team. On to the third question today, which is for the JC Bose team. Before we go ahead, Dr. Stanapati, I've got a question for you. A few weeks ago, you had this, may I call it an obsession with spherical objects.
Okay.
Today I find it's water.
Yeah.
What's it going to be next?
Water is the life.
Water is the life. Okay, JC Bose team, your question.
There are 3 glass bowls, identical. So they have same weight, same size, everything is same. But they are filled with water at different levels. This has maximum, this has minimum water in it. If I strike this bowl with a striker, metal striker, it makes sound. How? The sound of different pitch is created in different bowls.
When the metal object is striking against the surface of the bowl which contains water to the highest level, then we find that the sound of the lowest pitch, having the lowest frequency, is produced.
Yes.
This effectively happens because the height of the air column above it is minimum, and when we are striking it against the bowl, then what happens is that the air column, which is free to vibrate with the frequency of the already vibrating tuning fork or the metal object, decreases. Whereas in the case of the bowl which contains the minimum amount of water, when we are striking the metal rod against the bowl, then a lot of air column, if you consider the vertical height of the air column already present inside the bowl, then that is a lot more as compared to the first bowl. As a result, sound of the maximum pitch or highest frequency is produced.
But which one is vibrating, the rod or the bowl?
The glass bowl is vibrating and the air column is vibrating because it is in contact with the glass bowl. And since the water column is the lowest in the beaker which has the least water, so the maximum wavelength will be attained in the bowl which has the least water. So if the wavelength is maximum, then the frequency will be minimum, which has
frequency is minimum in the first bowl, maximum in the last bowl.
Here is the minimum, here is maximum. Now if I have a different striker, what will happen?
Depends upon the
depends on the frequency.
Something different from this.
no, it will only change the quality of sound, but the frequency will remain the same.
frequency will remain the same. So that's the right answer. Very good. I would like to explain in a different way. You know, the mass of this one is maximum and this has minimum. That is another way of explaining. Now the mass is inversely proportional to the frequency. More the mass of the object, less the frequency. So in this case frequency is less, and in this case this is maximum. So that is also another way of explaining the same thing.
JC Bose team, you pick up 20 points, you move on to 40. The next question is for the CV Raman team. Welcome back to Quest. The next question is for the CV Raman team.
In this test tube I have glucose, okay, and I am adding Fehling solution in it. Do you know what is Fehling solution? Cupric oxide. Then I will heat this for some time. There is change in color, and which is a precipitate. What is this precipitate? This red precipitate.
More orange, Dr. Sanapati.
Yeah, you may say, yes. Not red, orange.
Your time has begun, CV Raman team.
Is the red precipitate copper carbonate?
Are you asking me the question?
It's copper oxide.
One answer please, make up your mind, which is the answer? Trishul or Pooja?
I think the time is up.
Time is in any case is up. I
Okay.
think in all
You
fairness
try?
we should go to the other team. Yes.
The precipitate is cuprous oxide,
Cuprous oxide is right.
and this happens because the Fehling solution contains a solution of CuSO4, copper sulfate, and KOH, which forms copper hydroxide.
The basic thing is that
Yeah, cupric
And
oxide.
Cupric oxide, and the glucose is a reducing sugar.
Mhm.
It reduces the hydroxide to oxide.
Yes, which one is reduced?
The cupric
Glucose?
hydroxide,
glucose itself,
Or you are confusing the whole thing?
the basic thing is that the fact is the basically copper hydroxide is further decomposed into cuprous oxide, and the cuprous oxide is basically formed because of a redox reaction between glucose and Fehling solution.
You see, your first part, that this is cuprous oxide, is correct, but your explanation is not correct. So we have to go into the audience.
Into the audience. Anyone in the audience? No takers? None at all. Dr. Sanapati, I guess you'll have to do the honors.
Okay. I had mentioned that in glucose I am adding cupric oxide, which is Fehling solution. And this cupric oxide is reduced to cuprous oxide, whereas the glucose is oxidized to form gluconic acid. That's the correct answer. So no marks to either team.
half mark.
No, I'm afraid not. No half marks. No marks at all to you, JC Bose team. You remain exactly where you were. That's 40 points. CV Raman still on 20 points. The next question is on the buzzer. Welcome back. You're watching Quest, the weekly inter-school science quiz. We've covered 4 questions. Now we are into our buzzer section. As always, I'd like both teams to please note that when you hit the buzzer, you must have an answer ready with you. +20 if you have the right answer, -10 if you do not get the right answer. That's after hitting the buzzer. These questions do not pass to the other team. They'll go straight to the audience. The teams, if you're ready, the next question now.
I have one 1 meter long square aluminium rod. Okay. This can be balanced if I place my finger almost at the center of the rod. Now I am placing this on my 2 fingers, one on right hand side and other one on the left hand side. I will try to pull, or I will try to bring both the fingers towards the center at the same time. But you find the right hand finger is coming first, then the left hand one, then the right hand one, then the left hand, right hand, left hand, right hand, like that, like that. I come to the center and it is balanced. Why both the fingers do not come at the same time towards the center? That's the question. Yes.
Okay, Trishul.
So for a right-handed person, it's more convenient to pull his right hand first and then the left hand.
Oh, no, no, no. Not like that. Not like that. I can show you the other one also. Now see this one. Now the left one goes first, then the right hand. Left finger, right finger, left,
Moving them
right,
at the same time.
left, right, left, right. I am giving force simultaneously.
Anyway, -10 there. I'm sorry, Trishul, you've got that one wrong.
Goes to the audience.
Anyone in the audience with an explanation? You would like to try? Come.
I'm not sure about it.
Doesn't
Okay,
matter.
you can try.
No harm in trying.
Actually,
Your name is?
Hansen.
Hansen. Yes, Hansen.
Actually, when first he moves the right hand. So when he moves the right hand, then the
Remember, he's trying to move both hands together.
I'm trying
Why
to,
is it apparently that the right hand moves first, then the left? That's what the question is.
that's because he's trying to balance the scale. So
I think what we'll do, Hansen, is
Yes.
you hold this in your hand
And you do the same thing.
at the same distance. Face the camera.
Slightly different.
Okay, come. Further away. Not like that. Yeah. Right? You were trying to move both, but both were not moving together.
Both are not moving together.
The question is, why is that happening, Hansen?
because when you're moving the right one first, then the center of gravity it's turning towards the left. To balance that again, we move the left hand.
No, you are not making any effort to balance it. Okay, let me explain.
Okay, I think, Hansen, you don't have the right explanation. Yes, Dr. Sanapati.
I gave you a hint showing that if I place my finger at the center, it balances. That means the weight is distributed equally on both the sides. While placing the fingers, I have not placed both the fingers at the same distance from the end. One was short and the other was longer. Now the end on which the rod is having more length has more weight. In this case, the left hand side has more weight than the right hand side. So the right hand side will move first, right? After some time, here the weight is more on the right hand finger, and then the left hand finger will move. So like that, it will come to the center.
Welcome back to Quest. 40 points to the JC Bose team, 10 to the CV Raman team. Anything can still happen. Let's see what happens in the next question.
I have soap solution in this bowl. What I am going to do, I will blow 2 soap bubbles of different diameter, and you have to tell me what will happen if I stop blowing air further. A smaller soap bubble and a larger soap bubble. On one end of the tube there will be a large soap bubble, and on the other end it will be a smaller soap bubble. And if I stop blowing air further, what will happen after some time to both the soap bubbles? Okay, like this, right? A small and a large. Your time starts now.
Yes, JC Bose team.
What's the answer?
When the big soap bubble is blown, when we release the air pressure, the time taken for it to collapse will be more than the time taken for the smaller air bubble to collapse when we stop blowing air through it.
No, my point is, suppose you have a small soap bubble in this tube, at the end of this tube, and a large soap bubble at the end of this tube, and I am not blowing any air from this end. And if I hold like this, what will happen to the soap?
Both the bubbles will have equal diameter, means the pressure inside will equalize, and the diameter of both the bubbles will become
So
equal.
you mean to say the smaller one will become larger and the large one will be
Smaller.
will become smaller. That's a very wrong answer.
-10.
First of all, I have to show you what really happens. It is the opposite. The smaller bubble becomes smaller, and that air is passed on to the bigger bubble, which becomes larger. The reason is the inward pressure inside the smaller bubble is much more than the inward pressure in the larger bubble, and this pressure is equal to 4T by R. T is the surface tension of this liquid and R is the radius of that bubble. So in this case, where the bubble is smaller, there the pressure is more. So from higher pressure it will go to the lower pressure. That's right. So the smaller bubble becomes smaller and smaller, and ultimately the entire air is passed on to the larger bubble, which becomes further larger.
So -10 then, JC Bose team. You move down to 30 points. The CV Raman team remain on their 10 points as we go into what's going to be the last question of today's quiz. Welcome back. You're watching Quest, the weekly inter-school science quiz. The very last question is on the buzzer. Let's see if they can equalize.
There are 2 beakers having steel ball in each of them. In one I am pouring water and in the other one mercury. The steel ball sinks in water, whereas yes,
The water ball floats because mercury is much denser than steel, so the relative density of mercury is higher than that of steel, so the volume of mercury displaced, which is the weight of the volume of mercury displaced, which is equivalent to the weight of the steel ball, is lesser than the volume of the steel ball, so it floats by the principle of flotation. While on the other hand, in the water beaker, water is less denser than the steel ball, so the steel ball sinks, and the law of flotation is not applicable since steel is more denser than water.
excellent explanation, but the question was also very easy. Okay, full
I think
marks
we can
to
still
JC
give them a
Bose
big
team.
round of applause. Dr. Sanapati, do you think Shaunak will also float on mercury?
Oh yes.
He would. Well, It seems the team JC Bose, that's the boys from Don Bosco Park Circus, they seem to be floating on a cloud all right, because they have won today with a handsome margin. Their final tally, 50 points. The C.V. Raman team remain on 10 points. So finally, we've come to the end of today's show. The scores, as you already know, JC Bose team are on 50 points, C.V. Raman team on 10 points. A small memento from Quest to all the participants. JC Bose team, well done. Congratulations. Don't look so sad. C.V. Raman team, well done. We hope you picked up some scientific tips here today. You have. If you like watching our show, please write back. Our address is Quest, care of Doordarshan Kendra, Kolkata, 18/3 Uday Shankar Saroni, Golf Green, Kolkata 95. We'll see you again next week with yet another edition of Quest. Till then, from all of us here, it is goodbye.